questions, you can type them in the chat or unmute at any time. So yeah.
All right, I'll get started with sharing the first.
Wait, Yolanda, Sai says he's in the waiting room.
Okay, I'll let him in.
I'm back. I'm here.
Okay. Hello, Sai.
Yolanda.
Okay, I'm going to start sharing the, we're going to start with the exponents slide, everyone.
Start recording before we start.
Yeah, I'm pretty sure I have.
Okay, yeah, you are.
Okay. So, what exactly are exponents? As you may know, like multiplication is just repeated addition, and exponents are repeated multiplication. It's a small number written above another number. Like this 3 right here, that's the exponent. And it means that you need to multiply 3 2's together. 2 times 2 times 2, which equals 8. And so you can see here, 2 to the 4th equals 16. All right, now you guys try it out. Type what 2 to the 5th equals in the chat. And Sai, if you could keep an eye on the chat.
Yeah, 32. That's right.
All right, yep. So you guys got it. The answer is 32 because 2 to the 5th means 2 times 2 times 2 times 2 times 2, which is 32. Oops. Okay, so when we use an exponent, we say that something is raised to the nth power. Like here, this is y raised to the 4th power. And this would be 5 squared. If it's to the 2nd power, you can say squared. If it's to the 3rd power, we often say cubed. All right, type what 5 squared equals in the chat if you know it.
Yeah, y'all got it. 25. Good job.
Excellent, okay. Now what is 8 to the 3rd power? 8 cubed. How's it going? Are you guys getting it? Remember,
Yeah.
8 times 8 times 8. All right, great job. Now we're going to move on to negative exponents. A negative exponent tells you how many times you need to divide by that number. It's repeated division instead of repeated multiplication. As you can see here, 8 to the negative 1st power equals 1 divided by 8, or 1/8. So then 3 to the negative 2nd power equals 1 divided by 3 squared, which equals 1/9. And here's another way, a fast way to find negative exponents. First, you convert the exponent to become positive, and then you just take the reciprocal of that, which is 1 divided by that exponent. And now on to operations. If you're adding variables with exponents, you have to change the coefficient, which is the number in front of the variable. As you can see here, we have 2x squared plus x squared. And the coefficient is this number here. This number also has a coefficient of 1, but we don't need to write that. And so you add 2 plus 1 equals 3x squared. If you are multiplying numbers or variables with exponents, you have to add the exponents together. As you can see here, x squared times x equals x to the 3rd, because that's basically x times x, x times x equals x to the 3rd. And now, if an exponent is raised to a power, as you can see here, x squared is being raised to the 3rd power, then you have to multiply the exponents. 2 times 3 equals 6. If you're dividing two exponents, then you have to subtract the powers. As you can see here, it is x cubed divided by x squared, And so you get x to the 3 minus 2 power, or just x to the first. Anything raised to the power of 0 is equal to 1. That means that even the most complicated expression, if it's raised to the power of 0, the whole thing equals 1. And down here, you can see why this works. We all know that 2 divided by 2 equals 1, but you can also write that as 2 to the first divided by 2 to the first equals 1. And going back to this rule of division, where you have to subtract the exponents, you can write this as 2 raised to the 1 minus 1 power, or 2 to the 0, which would still equal 1. Here are some example problems. All right, find x to the 4th times x to the 5th, and everything divided by x cubed. Here's where you might need some paper and a pencil, so feel free to work this out and type your answer in the chat.
Can you repeat the problem?
Okay. The problem is the quantity of x to the 4th times x to the 5th divided by x to the 3rd. You should be able to see it on the screen. I'll give you about another minute to work it out. Okay, it looks like you guys are getting a lot of different answers, but I do see a bunch of correct ones as well. The answer is x to the 6th, and here's why. First, we multiply x to the 4th times x to the 5th, where you have to add the exponents, and that equals x to the 9th. Then you divide x to the 9th by x cubed, and you get, and here I think is where a lot of you made the mistake. You have to subtract the exponents. So it's x to the 9 minus 3 power, or x to the 6th. Does that make sense to everyone? You can, if you have any questions or want me to explain again, you can type it in the chat. Don't worry if you mistype it. It's fine. We're just seeing what you know when we ask these questions. And here's the next one. Find x squared plus x squared plus 3x cubed plus 15x squared. You'll need to simplify this expression. And as always, type your answer in the chat. All right, so here is the answer. It is 3x cubed plus 17x squared, because you can add together all of the terms with x squared. That is x squared plus 15x squared, which would equal 17x squared since you're only adding the coefficients. You can't add the x cubed term to the x squared term though, because the exponent isn't the same. And that's why the answer looks like it does. All right, next example. Go ahead and work it out. Remember, if you have an exponent of an exponent, you need to multiply the two powers. All right, great job. It looks like a lot of you are getting it. The answer is x to the 12th power. Oops. And that is because first you need to solve what's inside the parentheses, and you subtract 2x to the 6 minus x to the 6, which leaves you with just x to the 6th. Then you raise that to the second power, you multiply the exponents, and you get x to the 12th. All right, now we have some more problems. A lot of these are going to be word problems, which might be more similar to what you would see in math counts. Ooh, crap. Okay, well, I accidentally shared the answer to that one. So I guess we'll just go with the explanation now. So the question, there are 6 to the 4th grains of sand in each bucket, and there are 6 to the 3rd buckets in a room. So you need to find the total grains of sand. And so here, you multiply 6 to the 4th times 6 to the 3rd, and you need to add the powers to get to 6 to the 7th. I hope that makes sense. Okay, next one. Make sure you read it carefully. It's not as hard as it looks, I promise. Okay, great job. You remembered that anything to the 0 power is 1. And here's problem 3. 3/4 cubed. All right, great job. You got it. It is 27 over 64, because first you have to cube 3 in the numerator, then you cube 4 in the denominator, and then 3 cubed is 27, 4 cubed is 64. All right, now I'm going to stop sharing for a moment because I need to let Sai back in since he's having problems with his internet. Okay, yeah, I let everyone back in. So sorry if you were waiting, guys. Okay, back to this. Now we're on problem 4. So express 4 to the 16th in terms of 2 to the x. Now you should remember that 4 is 2 squared. This one's a little bit harder, so don't worry if you don't know how to do it.
Yeah, everyone's right. It's 32.
Yep. 2 to the 32nd power. Because because 4 equals 2 squared, and then you have to raise that to the 16th power. You multiply the exponents and you get 2 to the 32nd power. Sai, if you'd like to.
All right. So,
Problem.
all right. So,
I'll make it show up eventually. Okay.
okay. So 1 over 81 in terms of 9 to the power of n. So this problem is going to deal with negative exponents. I'm pretty sure you guys learned that during the presentation. Yeah, it's -2. Good job. Right.
Nice job. All right, so as Sai said, it's negative exponents. So 9 to the negative 2nd power equals 1 over 81. Okay, now we finished this presentation. If you guys have any questions, you can put them in the chat. But if not, we're going to move to another topic. Okay, Sai, I think you can share the presentation now.
All right. So, okay, we'll be doing a prime factorization. All right. It's just going to load in. It might take a little bit of time, but I should be able to get that up and running. All right, so actually it'd be nice if some of you like turned off your cameras because it kind of makes everything just slower. So there's like a high latency.
Also, apologies to the person who wasn't let in. I couldn't see the waiting room while I was presenting, but we will post a recording of this so you can go back and watch the part you missed.
All right,
Sorry
so,
about that.
right. Internet issues. All right. All right, okay. So right now we just did exponents, right? So we're gonna be moving on to LCM and GCF. All right, so I'll be sharing my screen now.
It hasn't shared yet. Okay, now it's good.
Cool. All right, so Oh wow, this is weird. All right, so everybody can see the screen, right? Can everyone see?
Yep.
So LCM and GCF. So does anybody know what LCM and GCF stand for? Like, just unmute yourself.
I do.
Least common.
I do.
Greatest.
Least common multiple and greatest common factor.
What she said. I mean, whatever they said.
Okay, so next time onwards, I'm just gonna call one person, and I only want that one person to unmute themselves and answer the question because it can get a little. So everybody said LCM stands for least common multiple, and A and B refers to the smallest numbers divisible by both of the numbers. So if I have the LCM, let's say 5 and 10. Does anybody know what the LCM of 5 and 10 is? Let's go with Anand Kapoor. Can you tell me what the LCM of 5 and 10 is?
10.
It's wrong. It's actually 5. And the reason
I can't hear you.
starting with the GCF, you're right. Good job. The answer is 10. So it's 10 because 10 is obviously just a multiple of 10 because 10 times 1 is 10. And 5 can be multiplied by 2 to get 10. So the least common multiple of both of them is 10. But the GCF, or the greatest common factor, is the greatest factor of both of them. So what is the GCF of 5 and 10? Can anybody tell me? Let's go with, I'm going to call on someone. How about, let's see, Gary, I think. Is that how you pronounce it? Can you tell me what the GCF of 5 and 10 is?
The GCF would be 5.
Correct. The GCF is 5 because 5 is a factor of 12, and 10 and 5 is also a factor of 10, right? Because 10 has the factors of 2. That would be the greatest common factor. All right. So prime factorization is basically when you use the tree method. Well, there's not just one specific method for prime factorization, but the most common method that we use is the tree method. What you do is you find a prime number that is a factor of the number, and then you use the divisibility rules to help you. So what you do is you divide the original number by the prime number, and then you keep on repeating until all you're left with is prime numbers. So let's take 60, for example. All right. So I'm first gonna split 60 into 2 and 30. All right. Then I'm gonna split it into, I think, the tree. You guys can see the tree, right?
Yeah.
Yeah, so I'm basically splitting it, right? I'm basically splitting it into like these different numbers until all I'm left with is just prime numbers. So I have the 60, then I have the 2 and 30, then I'm splitting the 30 into 3 and 10. So 2 and 3 are prime numbers, but 10 isn't. So then we're gonna split the 10 into 2 and 5. So at this point we have all the numbers we're left with are prime numbers. It's important to make sure when you're doing prime factorization that like you list the numbers in the least to greatest order. So 2 is less than 3 and 3 is less than 5. So we're gonna list it like this. And also, you notice how I put 2 squared instead of 2 times 2. That's important as well. You need to make sure that you're putting the correct exponent for the factor. All right. So how do we find the LCM? So when you find the prime factorization of both the numbers and write them out, and then then after that you find the term with the highest exponent value. So I think we should just jump into an example because that might make it a little easier. So let's say I have the number, I'm gonna give you guys a simple example. Let's just go with 5 and 50, all right? So how do I find the least common multiple? Does anybody know? All right, I guess I'll just say it. So I have 5 and 50, all right? So the least common multiple, what's the prime factorization of 5? Can anybody tell me the prime factorization of 5?
5.
5, that's right, all right. So what's the prime factorization of 50?
5, 5, and 2. Or 5 squared and 2.
Yeah, but like how like in the last slide I told you that there's a specific order you put it in. You put it from least to greatest, okay? And then you put the exponent. So 5 times 5 is 5 squared. Like, can anybody tell it to me in like that specific order?
2 times 5 squared.
5 squared.
Yeah, that's great. So 2 times 5 squared is the prime factorization of 50, and the prime factorization of 5 is just 5. So what is the least common, so then for each distinct prime number, we have to find that term with the highest exponent value. So, okay, so 5 is a distinct prime number, all right? So the term with the highest exponent value would be 5 squared, because 5 squared has a higher exponent value than just 5, because just 5 is 5 to the first power. So then, but we also have that 2, right? So when we have that 2, like the 2 is like, that's the only 2. That's the only 2 and it's distinct. So we basically take that 5 squared and we multiply it by 2 and we get 50. And that's how we get the LCM. I think we should practice a few more examples. I'm gonna give you guys a few more, like 36 and 5. 36 and 5. So I want you guys to do that out like on a piece of paper. All right. And I'm going to call on, actually just write your answer in the chat. What is the least common multiple of 36 and 5?
All right, we have an answer of 180 in the chat.
So
Excellent job, guys. You're all getting it.
I'm going to do one more. Sorry. I think I went a little too forward in the slides. Are we in examples? All right, cool. We're in examples. GCF. Okay, sorry. We're in LCM. I'm going to do one more because this is just really important. Like, it's really important to like get. Let's do like 6 and 21. What is the LCM of 6 and 21? I'm gonna like do this one out for you guys as well. Like, so just first put in the chat if you know the answer, and then I'll actually do the problem out for the
What's the
people.
other number again? 6 and what?
21.
Oh, okay.
I'm just gonna write it here. 6 and 21. Can you guys see that?
Yes.
6 and 21. Cool.
Yes. It's a bit weird, but we can see it.
All right.
All right, it seems that everyone's pretty much gotten the answer of 42.
All right, that's good. But let me just like do it because like the methodology might be a little confusing to some people. So the prime factorization of 6 is just 2 times 3. All right. And the prime factorization of 21 is just 3 times 7. All right. So the highest, okay, so we have 3 different distinct prime numbers, okay? And these values are 2, 3, and 7, all right? All of these values don't have higher exponents. So the greatest distinct value of each one is just 1. So we just multiply 2 times 3 times 7, and we get 42. But let's say I change the 7 to a 7 squared. Okay, can anybody tell me what would happen then if I change the 7 to a 7 squared? Let's take Shalok. Can you tell me what happens if I change the 7 to a 7 squared for 21's prime factorization? So let's just make this. So this isn't 21 anymore, all right? This is 147. This is a new number. All right, so what would happen to our least common multiple if this squared was added? The square was added, right? Because before it was just a 7, now we added a square. All right, I guess you're not going to answer, but I'm just going to tell you. So what would happen would be like, because I told you that we have to take the greatest exponent for each distinct prime factor. So 7 is not the greatest exponent. We would change that to a 7 squared. So then we just multiply this over 7, and we get 294. All right, does everybody understand this? unmute your mics because I just want.
Yes.
Okay, good. Everybody
Yes.
understands
Yeah.
exponent, right?
You wait. So you do 2 times 3 times 7 squared.
Yeah, but I did that 7 squared because 2 was the greatest exponent, right? So let's say I have 2 times 3 and 3 times 7. Okay, let's just take out the 7 squared. If I change this to a cube, then I would take the 3 cubed instead of just the normal 3 because this is the greatest exponent. You understand?
Okay, yeah, now I get it.
Okay, that's good. So next slide. I think I'm having technical difficulties. 1 second. All right. Oh, everybody can see these, right?
They're not
Is
still.
kind of on it.
Let me just go to the next slide from here because it's kind of like getting little. All right, present. Okay, so now we're at the examples. I'm obviously gonna have to take out the God, the
Do you want me to like share it?
yeah. Wait 1 second.
Give me
Just take
host
out-
permission back. Oh, okay, there's an eraser. That works.
Yeah. All right, so I'm just gonna take out all these weird annotations because nobody wants to see those. All right, so let's go to the next slide. Ah, seems like my computer does not want to work with me today. It's really
See if pressing the arrow buttons or the
yeah,
space bar does anything.
yeah. I don't know. It's just like not cooperating.
Maybe if you go out of the eraser. I don't know. That's weird.
Yeah, it really is. It's
Because you guys only have like 10 minutes left. Like,
all right. Here, okay. We got a question. Oh, sorry. I gave you guys the answer. Okay. Does anybody know what the LCM of 24 and 52 is? Why is the answer keep on displaying? Just do it on the just give me your answer on the chat. Annotate.
Okay, yep. Everyone's saying 312.
All right. Good. Good. That's good. That's the correct answer. Now, we'll go to the next slide.
Okay. Everyone find the greatest common factor of 2,880 and 2,268. This might take a while since they're very large numbers, so take your time.
All right. Okay. The mute went. Okay. The thing wasn't like showing up because of a participants thing, an annotations thing, and a slide thing. So there's just a lot of things. All right. Question. So, did anybody get the answer yet?
Yep,
All
but
right.
kind of showed it also.
Yeah, you showed the entire thing like twice.
I mean, technology. Okay, so lessons have a ton of tabs. It's very complicated.
A lot of things like. Hang on. All right. So 36. Okay, everybody already knows that answer, I guess. Move on to the next one. Okay, example 3. Okay, I hope I don't leak the answer to this question because that would really suck. Ah, well, I guess I did it.
Okay, the chat says 126 to 1.
All right, so That's good, but I actually want to show you guys something that's really, really important, all right? So basically, I don't know if you guys knew this, all right? But, annotation. But if you multiply 1,134 and 729, then that's the same as multiplying the LCM and the GCF. So, let's see. Nice, okay. So, the LCM of 729 and 1,134 is the same as the LCM, and then if you multiply the LCM of these and then the GCF of the same thing, then that equals 700 and the product of the numbers. So the LCM and GCF of two numbers is equal to the product of those numbers. So this is just something really important because it can just really help you, like, not waste so much time in doing like harder problems like these. They use bigger numbers because there's more room for error. All right, we're good on that, right? That's just important. That's just an important thing. All right. I'm just gonna wait a little bit for people to get the explanation because this is kind of a harder problem. So I did not expect everybody to like solve it like quickly, really.
Yeah. Okay, so some people are a little bit confused on how you get GCF.
All right, okay, we'll just do this. We'll do the GCF again. All right, let me use my eraser to erase all this. All right, cool. All right, so let me show you how. All right, so the GCF of these two numbers can be found by using, first we take the prime factorization of 729, all right? So I do know, because I know my divisibility rules, so you guys might not know your divisibility rules yet, but that's just gonna be 9 times 81, and that's just gonna be 9 times 9. So basically we get 9 cubed. Can anybody convert 9 cubed into 3 to the power of something? Because I know that this was one of our example problems. Who said that? Can you say it again?
3 to the power 6.
That's correct. Good job. So that's just going to be 3 to the power of 6. So, and then let's just do 1,134. First, let me erase all this. All right, now let's just do 1,134. 1,134. All right. So again, this is something like you need a little divisibility rule knowledge, a little thing prior. I don't know if all of you guys know your divisibility rules, but it is something that we will be covering. So I know that this is divisible by 9, so I'm going to take that 126. So see how I'm breaking it down. Then I'm going to do it again. I'm going to take that 9, all right? And then I'm going to break it down. I'm going to give this a 14. And then I'm going to break the 14 down into a 2 and a 7. So, can anybody tell me the prime factorization of 1,134? Like, I gave you all the factors, so it shouldn't be too difficult. This is a 9, by the way, if that wasn't clear. So I have a 9 here, a 9, and a 2 and a 7. So what is the prime factorization? Somebody unmute yourself, please.
2 times 7 times 4 times 9 to the second.
Okay, that was a pretty good guess. But 9 is not a prime number, right? Because 9 can be broken down into 3 times 3 or 3 squared. You understand? That was a really good guess, though.
I
So
didn't notice that. I forgot
well,
about
it's okay. It's okay. So we have 2 9s. So let's just do this. 2 times 7 times 9 times 9, right? So each of the 9s can be broken down to 3 squared. So that means this is actually 3 squared times 3 squared. Can anybody tell me what 3 squared times 3 squared is? Anybody?
81.
Yeah, but put that as an exponent.
3 to the 4th.
That is correct. 3 to the 4th, all right? And then, so then we have 2 times 7 times 3 to the 4th, but something about this is wrong. Can anybody tell me why this is the wrong answer? Why is 2 times
About the
7?
multiplication.
It's on the right order.
Yes, it's
Yeah.
not. That's perfect. Yeah, whoever said that, good. I have to put 2 times 3 to the power 4 times 7, all right? So that would be the correct answer. But that's not the goal. Our goal is to find out the GCF. So then we're going to have, then we know that the GCF of 729 is 3 to the 6th, all right? Does anybody remember how we find the GCF? Nobody? Okay, well,
You find the like biggest factor of both numbers.
perfect. Yeah. You find the common factors of both of the numbers, all right? And you find the biggest one that they both have. So these both, okay, so 729 doesn't have a 2 or a 7, but it does have a 3, doesn't it, right? It has a 3. So if I put 3 to the 6th here, right, I can take 2 to the 6th, but unfortunately, this number can't have 3 to the 6th since it only has 4 3s. Well, this number has 6 3s. So let's just take 4 instead. So if we had 4, this has 3 to the 6, right? So 4 would work. So the answer would be 3 to the power of 4. And what is 3 to the power of 4?
Wait, what?
81.
I'm so confused.
Okay, so for 3 to the 4th, you can see the prime factorizations of both numbers, and then you look for which numbers are the same in both the prime factorizations. So,
Okay, I get it.
so
Wait. What?
4,
Can you
3.
tell me why you're really quickly? Because I need to understand. Because
Now
I'm
I get
pretty.
it.
Are you sure?
Yeah, I'm sorry.
If we
So
do
you find the number that both of them have
don't-
and then you use that.
All right. That's good. Okay. Well, I hope you got it because these stuff are pretty important. Yeah, so let me do that one more time. I'm not going to do it one more time, but I'm just going to explain it to you one more time. All right. So what we're doing is just finding the we're just finding the prime factorization of the numbers, all right? And once we find the prime factorization, we're basically finding the greatest common factors, like the factors that they both have, and we're just multiplying those. You understand? Okay, this is a new question. All right, I think I messed that up. All right, so LCM EF. This is a little harder problem. All right. This is gonna be our last problem because we're a little over time. But after this problem, you guys are free to go. It's not good. Eight. Okay, so has anybody solved it yet?
I'm pretty sure everyone just saw the answer, but maybe we should just end it here.
Yeah, we should just probably end it here, but let me just explain this last one. All right, let me read it first. LCM of E and F represents the least common multiple of E and F. Okay, find the LCM of 6 and 14 and the LCM of 12 and 18. So this is like a mouthful. This is a lot, and like at first, like a lot of you guys might not understand it at all. All right, but it's actually kind of simple. All right. So all we're doing here, the answer just got leaked again. So all we're doing here is just finding the LCM. Okay, so of the LCM of these two numbers. So what is the LCM of 6 and 14? Anybody, just tell me, somebody.
42.
42.
42. Great job. Okay. What is the LCM of 12 and 18?
36.
36.
36.
So then here we're just finding the LCM of 36 and 42. Bam, that's the entire problem. Just the LCM of 36 and 42. And what is the answer to that?
252.
252.
That's right, because all we're doing here is finding the prime factorization of 36, which is just 2 squared times 3 squared, and finding the prime factorization of 42, which is just 2 times 3 times 7, all right? And now we just take the greatest, now we just take the common multiples, the greatest common multiples of each one, so 2 squared, okay? And then 3 squared, and then 7. And then we're just going to multiply all of that, so that's just 36 times 7. And that is 252, and that is the correct answer. All right. And that's the answer. Yep. You guys got it right. Yeah, I think you guys got it right. So
Right.
I'm just going to.
We don't want it to be too long, so we'll end it here even though we haven't finished all of the problems we have. We are going to have a quiz on some of these concepts, which will be posted in Google Classroom very soon, later today. So, and we'll also have the recording up so you guys can review this lesson. Since it did go kind of fast, so you might want to go back and replay the explanations so you do better on the quiz.
All right. Does everybody understand these concepts of LCM and GCF? You guys also need to understand the prime factor tree because that's pretty important. Okay, stop sharing. Okay, so some things you guys need to understand are the prime factorization, how that works using the tree method, finding the LCM and the GCF, and that's all you need to know. So a lot of you guys understand the concepts, but like it's really hard to apply. Like for this problem, I don't know. A lot of you guys may have saw the answers and put it, but like I trust that you guys actually did the problem out. But for a lot of these problems, it's just hard to really understand the problem. So understanding the problem is probably the most important skill in problem solving. And then understanding the concepts is like probably like the second most important skill. Okay, I hope everybody understands. Okay, you guys are all free to go. You guys can just go now. All right, bye. Bye, everybody. I'm ending this.